Hi, I will present recognition with R CNN. So this work is done by the team of Jitendra Malik from UC Berkeley. There is also Girshick that he works on. I think he used to work for Microsoft and now he works on Facebook. Well, the paper is about recognizing actions in images. So we have as input, we have an image, and we try to recognize some action. So the R*CNN is based on RCNN, that it's for object recognition, for object detection. So the idea of the paper is that, well, we have a person in an image. So, for instance, we have three persons one person in these three images, and well, we can find them. So we need some cues, some contextual cues, to know that they are doing a specific action. So the first person, it's calling someone using a phone, a cell phone. The other one is taking a picture. And the last one, well, it seems that he's playing some kind of instrument. And it's not a piano. So the paper, the idea is that, well, we have to use these secondary regions of the image to detect, to classify the action. Okay. So we have to talk a little bit about object detection before going to R*CNN. So, okay, yep.
So that the action needs to be performed by the person? Or?
Yeah. Okay, well, sorry about that. So, object detection. In object detection, you have to find the objects in an image, and to do that, you have to give a bounding box of that object and some measure of confidence. So in this image, as you can see, it's the image of the street, and we have to find the cars. So the wish output should be 7 cars in the street. So in order to do that, well, now the usual way to detect cars is doing that into steps. The first step is that you should propose some regions of the image, some windows for Fourier classification. So in this example, you can see that we found 4 cars and there are a lot of windows down here. So additional steps involve that you should filter the output. So we can filter a little bit here and we discard some window. Now, the second step is that you classify each window. So in this case, well, the classifier mark these ones as cars and this window as car. So again, we have to filter the results. But sometimes, as in this case, you could do some detections. So at the end, we found just 3 cars in this case. Okay, so that's the framework for detection. So the proposal method, famous proposal method that now almost everybody uses is selective search. So selective search works on an image. First, it performs some segmentation at a low level, and then makes hierarchies to propose windows. So as you can see, this cow, it was made by a lot of brilliance. And at the end, you got a lot of proposals. So here is a cow, here is the other cow, but you can also get the sky and the grass and many kinds of, uh, of regions of the image. So at this point, you are not learning anything because you are just making a grid immersion of the regions. So the next step is to use a classifier. So with this architecture, we have the classifier that now everybody uses CNN. And here it comes the RCNN. So you can see that here is the proposal method. They use selective search, and then they use CNN. You can use any CNN on this pipeline. So here, the problem with the first RCNN, it was that it is slow, because for each region that you propose, you have to pass it through the CNN. So that makes it really slow. They do further research, and they found that in the first layers of the CNN, you can perform sharing computation on the image. So that was one step further. This paper only talks about fast RCNN, but there are faster approaches like faster RCNN. So finally, I can explain the RxRCNN. So initially, you have an image. You also have the bounding box of a person in the image. And you have a set of actions, and you want to classify what is doing that person in that picture. So in this case, it's taking a photo. Okay. So the paper states that you have this primary region, and you want to find a secondary region that it will work as a contextual cube. In this case, well, you wish to have the camera, because it will tell you that the picture is taking that the person is taking a picture. So initially, selective search will give you hundreds of regions, but you already know which one has the person, and you have to. The first step is that you have to determine the overlapping boundary boxes. In this case, are the green ones. So you have to state it with the L and U. So the next step is to tell which secondary region give us a description of the image, so we can determine what the so here comes the CNN. So here the first layers are the convolutional ones. So here they share computation. So we can explain a little bit about the equation here. Well, you can see that, well, it's the CNN, it's almost the usual one. The only thing that it's different is these layers. The one in the up, it's for the primary region of the image. And for the secondary regions, we have the green ones. As you can see, if you have three proposals for secondary regions, you must have three layers for each region here down. So the name comes from the star in the R star CNN name comes from this point. So if we had 5, we must have 5 layers. So it's almost the processing is almost usual. But we have 5 secondary regions. 5, and let's suppose that we have another one here, and we can have another one here, down. We can have many.
It's maximum, so you can say
During training, you can see that, for instance, here in the training, we have one image, but we have different secondary regions.
and from there what we change in making the architecture. I don't understand what we change in the architecture.
Well, you
You replicate the bottom layer.
yeah, the bottom layers here, there are 3, 1, 2, 3. So
Okay, yeah.